Robert Lee, and I am presenting my lab 2 for charge tape revisit. So some goals for this lab are going to be very similar to the first one with trying to levitate basically one tape with the other. But this time when we're going to estimate the charge, we're going to use a new formula that is using assuming that the piece of tape is an evenly distributed charged rod. So some things we're going to need to know are that, of course, Newton's second law where F equals ma, this time it's going to be 0 because it will be floating at static equilibrium. Then gravitational force, the thing pushing it down, is just mg. Electric force is what is pushing it up, so it's defined right there by the Coulomb's equation. Then this time, this is the equation we're going to be using to calculate Q with electric field being an evenly distributed charged rod. So some assumptions we're going to make is that that the charge is evenly distributed, very important, of course, in this case, then no air resistance affecting the force, and then that both tapes are charged exactly the same. So here are the findings we found this time around. Of course, still has a positive charge, but the charge is 2.719 e to the negative 8 this time compared to the 1.47 e to the negative 8. Deficient 1.8 e to the 11th electrons. So this is the same procedure we had from last time where we're putting the two pieces of tape and trying to hover it. So of course the observations are the same. Most importantly is that the tape is negatively charged. When it's compared with the negatively charged pen, it's attracted to each other, so that's how we know it is positively charged. Here is the separation distance measurement, 0.0323. And then here's the free body diagram. So 1 is, the electric force pushing it up, and 2 is the force of gravity going downwards. So here's the data that we are going to input into this equation right here. So this equation just for electric field, but if we compare this to gravity, we're going to set them equal to each other, and then bottom left you can see we're setting Q equal to mg and calculating Q from there. So from that we got Q equals 2.719 e to the negative 8 for the new calculated charge. So here's the glow script that we used. You can see in the top left script at the bottom of it, we plugged in our estimate, or we just kept plugging in new numbers to try and get the forces to cancel out, and we ended up with this 2.91668 e to the negative 8 for the value. You see that at the bottom where top tape equals line charge, that function is basically just saying that it was 0.0323 meters away. Then top right function is how we calculated each electric field from a single particle. So basically how we did that, how we're using this is that if you can see n equals 30 for the charges, we basically said there's 30 point charges on this tape, and how would those 30, how did their electric fields look? So on the bottom left, we're, iterating through each piece of charge and calculating that. So then here are basically, this is just the script to calculate the arrows, and this is what we got. So, 1.96 or e to the negative 3 was the force, and this is, it looks pretty good. So the true charge we found was 2.916 e to the negative 8. Still deficient 1.8 e to 11th electrons. So maybe some sources of error were that we were handling the U-tape with our hands, so some electrons moved around and transferred. Also, we definitely did not use the U-tape in perfectly parallel fashion. That's just impossible with humans. And then also, of course, human eye error when we were measuring each value. So some final thoughts, what if we had modeled it just like a single point charge like last time? So comparing these two data, we got almost 2 times the value this time than the last time. 1.47 compared to 2.7. So 1.85 times the value. Why do these estimates differ? This is because point charge model is not really similar to what the tape actually was. The tape was way more similar to an evenly distributed rod, which is shown with the final results. The point charge was only 26% of the true value, while the line charge rod was near 90. So yeah, the piece of tape is a much better way to calculate this charge.